Hey everyone, and welcome back to part 4 of this video on the Bernoulli equation. In this part, we're going to be looking at an experimental apparatus we can use to explore the equation a little bit further. Here we can see the apparatus. The way this works is water is brought to our experiment along this tube here before entering this middle section where the experiment takes place. In this middle section, we find a pipe flowing with a constriction in the middle and a series of tubes attached at different locations. Each of these tubes takes a pressure reading at that specific location and then displays that reading on these piezometers we can see here above. We'll add blue lines as it's hard to see the transparent water. We should be able to predict what the pressure readings will be based on our new understanding of Bernoulli. The water then exits out the other side of our experiment and is emptied out a tap in the back. So let's take a look at the experiment itself. So here we have our pipe with a constriction, and we're going to try and predict what the pressure changes are along its length. So let's start by turning it into diagram form. Importantly, the first thing we can notice is that it runs horizontally. This is important because it means when we're using our Bernoulli equation to compare two locations before and during the constriction, there will be no change in static head. They are both the same distance from the height reference line, and therefore the same values of static head on each side of our Bernoulli equation can simply be cancelled out. Or even easier, we can simply place our height reference line at the height of the two locations being compared. So our two values will be 0. What is affected, however, is our velocity head terms. We remember from flow continuity that a reduction in area during the constriction will be coupled with an increase in velocity of the liquid, and hence an increase in the velocity head during the constriction. As the total energy must always remain constant, the remaining energy up to the total energy line will be filled up with the pressure head. And we can clearly see the pressure head component is much smaller during the constriction, and we would expect this trend to be displayed on our piezometer readings. However, although we do see a clear drop in pressure towards the middle during the constriction, we don't quite see the symmetrical set of values we might have predicted from Bernoulli's equation. Most obviously, if we were to compare readings 1 and 6, which represent symmetrical locations on either side of the constriction, and we would therefore think from Bernoulli would have the same pressure values, we can see a clear loss in pressure in the later reading. Why is this the case? This begins to hint at some of the limitations of Bernoulli in this idealized form. In the next video, we will look at a more complete version of the Bernoulli equation with the introduction of an important new topic: head losses. Now, I hope this video has been helpful and you now feel you have a better understanding of how to use the Bernoulli equation and what the theory behind it is. And I hope to see you all in the next video.